For today, we're going to be solving more inequalities. The only difference is we're going to look at some of these special case inequalities that either will have no solutions or have all real numbers as their solutions. So you just have to watch this video and then do the bookwork. Here's the first example. Finding the solutions of 6n minus 1 is greater than 3n plus 8. So first subtract 3n from both sides to get it so that you only have variables on one side. And then if you simplify, you've got 3n minus 1 is greater than 8. And then to get all the constants, the regular numbers on the other side, we'll add 1 to both sides. Now we've got 3n is greater than 9. And we just need to divide. We're not dividing by a negative, so we don't have to switch the inequality sign. We get n is greater than 3. If you graph that, it's an open circle and goes to the greater numbers. So worth noting here is that at this step where I subtracted 3n from both sides, you could have subtracted 6n from both sides. You just would have ended up with a negative 3n then, and when you divided, you would have had to do some swapping of inequalities, and it would have been a little bit more complicated, but it still would be completely correct. So this next one is one of these special cases. So you can see when we apply the distributive property first, you end up with 10 minus 8a is greater than or equal to 10 minus 8a. So now if this were an equation, we would say that was an identity and it would have all real solutions. But let's see if this is different with an inequality. So adding 8a to both sides, and then we've got 10 is greater than or equal to 10. Since that's always true, the solutions are all real numbers. Notice that if it was just a greater than sign and not greater than or equal to, then it would have no solutions because 10 is greater than 10 is never true. So you have to be really careful with an inequality. Okay, so this is the other kind of special case, and so you should be thinking to yourself, how is this going to end up to be never true? So first notice that we've got two like terms. We've got 7m minus m on the right side. And if we combine like terms, we've got 6m minus 5 is greater than 6m plus 7. And then we can go ahead and subtract 6m from both sides. And we're going to end up with negative 5 is greater than 7. Since that's never true, this has no solution. There's nothing you could ever put in for m that would make this a true statement. So using those two special cases and the types of inequalities that we've solved before, here's your bookwork, numbers 29 through 43 odd. You'll be turning them in tomorrow on Tuesday, so make sure to do them on a separate piece of paper, check your answers, all that good stuff.